Of course. Stephen met Red Whitaker before coming to CMU on a 2-hour-long car ride through the Chilean desert. And that's all I know about this very mysterious story.
We can talk about that later. But
okay.
That was also when I was 19 years old, and was before I got into academics really at all.
Oh, wow.
So it was like my first exposure to research. It was really a unique one. So what I'm going to talk about today is about creative problem solving and what sort of strategies, creative strategies, help people perform better on creative types of work. There's very little research in this space. There's stories like the story that Bill Buxton shares in his book about a ceramics teacher who comes to class the first day and splits his class up into 2 groups. He tells the first group, you're going to be graded entirely on quantity. So produce as many ceramics as you can. At the end of the semester, we'll put them all on a big scale, and that'll be your grade. He tells the other half, just work on creating 1 good ceramic. I don't care what else you do in the semester, your grade is going to be dependent on that 1 ceramic. And what happened throughout the course of the semester, as Bales and Orlin report, while the quantity group was busily churning out piles of work and learning from their mistakes, the quality group sat theorizing about perfection. And in the end, had little more to show for their efforts than grandiose theories in a pile of dead clay. So iterative, deliberative practice led to better results in this case. And while some people resonate with this story, others push back and say, well, this isn't how it works. In the real world, when we have real deadlines and constraints that we have to work under, it would be nice to create as many variations as possible, but we just don't always have time to iterate. So it raises a question about how our practices, how our design and engineering processes affect the end result. So there are schools of design throughout the country. This is a picture from Stanford School of Design called the D School. And they teach a particular strategy, a design strategy called design thinking. And you walk into this space and it's kind of what you think of as a design environment. Rolling whiteboards, lots of sticky notes all over the place, ongoing student projects. And you also see signs of faith or belief in this process. There's a commitment, sort of a faith in the strategies that they use, but very little empirical evidence on what matters. And that's where this research comes in. We're going to present a series of experiments that explore how our prototyping practices impact design results. But how do we measure creative results? Scientists have long been interested in creativity. One classic design experiment is the 9-dot problem. So the task here is to connect these 9 dots using a pen with 4 straight lines, and you cannot lift the pen. Does anyone know the solution to this, or has anyone seen this problem before? So you typically see this in cognitive science classes. And where people get hung up is they think that, I have to either curve the line or somehow bend the paper or something like that. And they typically frame the problem inside these 9 dots, where the solution is actually to extend beyond the lines. And that phrase, thinking outside the box, came from this experimentation. And so these researchers will use this problem and measure how long it takes people to solve it. That becomes sort of a dependent measure in an experiment. Another approach has been to ask people to come up with alternative uses for an object. So given a brick, what are all the things you might use that for? In a structure, you can use it as a paperweight, you can use it as a weapon. What other sort of creative uses for a brick? Doorstop. Signpost.
Counterweight.
What was that? Counterweight.
Nutcracker.
What? Nutcracker. Okay. So think of different ideas, and what they'll do is they'll add up the number of ideas people come up with. That gives you a number and some sort of measure of how creative, how fluid people were thinking. You can actually look at how different the set of ideas are from what other people come up with. So you can get the sort of the quantity of ideas and the uniqueness of ideas, give you some measure of creative thinking. More recently, researchers have looked at using sketching. So they'll ask people to sketch a creature from another planet. And then to measure the results, they'll put these in front of an expert and have them rate these sketches based on uniqueness or creativity. And all of this is very cool work and has led to interesting insights about how we think creatively. But as we started reflecting on real-world design and engineering practices and prototyping, we realized we needed a different petri dish, a different way of studying this. Unlike the 9-dot problem, we needed to have a design problem that had multiple possible outcomes. Like many of the problems we solve, there's no one solution, but many possible valid solutions. And we wanted some way to measure the results beyond just using experts. So we wanted some objective way to say that design, that solution is better than this solution. And so our initial experiment, our initial sort of entry into this space was to use the egg drop design task. So here I am in my office at Stanford, dropping an egg vessel out the window, and this is the egg that survived. So what we had people doing is creating these mechanical vessels to protect a raw egg from a fall, using everyday materials like tissue paper and pipe cleaners and cardboard. And our dependent measurer in this experiment is going to be how high can you drop the egg vessel, until the egg cracks. So we're going to drop it from 1 foot, 2 feet, and keep dropping it until the egg eventually cracks. And we did that experiment. We did a between subjects experiment with 28 participants, and half of them were told to rapidly iterate. The other half were told to create one perfect design. And everyone came up with a very different idea with varying degrees of success. And the results showed quantitatively that those that were encouraged to rapidly iterate did produce better vessels. The eggs survived from a higher height and under the same time constraints. But what was really interesting, I think, from this experiment was not necessarily the quantitative results, but it was what we were seeing qualitatively in the interviews. Do you have a question?
Well, yeah. How prepared were they to theoretically build? How prepared were they theoretically to build, a safe? What do you call it?
Egg vessel.
Yeah, egg vessel.
People did have different levels of experience. Like some people had done it before and others had not. But I think it was the fact that, overall we had about the same number of people that had done it who had not done it across those two conditions. So I think one of the things that we can get into later is the people who were sort of perfecting their design, what kind of things were they doing and thinking about as they were solving the problem, and some of the other interpersonal differences we noticed. So can get into those a bit later. But one thing that sticks in my mind, for example, is the folks who had formal mechanical engineering training actually ended up performing just about the same, or if not a little bit worse than some of the artists and others, because they were perhaps overthinking the problem. And one of the benefits of rapidly iterating and trial and error is that you get a lot of feedback from the particular domain that you're working in. And so we saw people talk about how they didn't realize some of the issues they'd run into. So their initial plan was to cushion the initial bounce of the egg vessel. What they didn't realize, and what they figured out through testing, is that it bounces, flops to the side, and that there's a secondary, sometimes a third point of impact to account for. And these were all discovered kind of through the process of making solutions and trying them.
Were they allowed to choose which type of group they were in?
What type of what?
Which group they were in?
No, it was an experiment. We didn't tell them how we were manipulating their process. It was a sort of experimental setup. They came in and we just told them what to do. And no one really questioned, what, it's like any experiment. You're not supposed to know what it's about. So we did interview people after they did these egg vessels. We had them talk about their process and the concepts they came up with. And one of the most shocking things for me was seeing people say that they picked an idea very early and stuck with it.
For some reason, this seems to be the only idea. There needs to be a platform, and then as good a cushion as possible with the materials. I don't see any other way.
I'm not a very good outside the box thinker, so I kind of just had one idea and I was going to try to make it work.
I kind of went with the whole parachute idea and what I had from the beginning. So
this is the best approach for
So the time constraints of the experiment certainly had an effect on how diversely people explore different ideas. But what was interesting is the mindset that they had, that they had considered all the possibilities, and this is the only way it could be. This notion of functional fixation actually has been around for many years, since the 1940s, when Carl Duncker did a series of experiments with the candle problem. And he would ask people to, he would give people actually these objects, a candle, a book of matches, and some tacks. And he would ask them to attach the candle to the wall above the table and light it so that the candle wax won't drip down onto the table. So do you guys have any guesses as to what the solution is? Huh? Yeah?
In the box to the wall.
Say again? You know this one, don't you? What was it?
In the box to the wall.
That's right. So the hidden insight here is that the box of tacks can actually be used to support the candle. And most people exhibit functional fixation in this problem in viewing the box's primary function as a container for the tacks rather than as part of the solution. And it turns out that if you give people the same problem and the box is empty and the tacks are spilled out on the table, so same material, same problem, people are much more likely, much faster to solve the problem. So just the configuration of the physical environment can affect how we solve problems, how we see those insights about problems. Yeah?
With the egg dropping experiment, did any of the people who were in the non-iteration group try to iterate? I mean, it's a natural thing to do.
Yeah, there's sort of a tendency to test it, kind of mini tests on top of the table. So we saw people doing what they can, shaking their designs and without the ability to actually do a full system test. There's definitely a tendency to do that. So another line of experimentation is to kind of look at what what people's natural tendencies are to try to iterate, and is iteration undervalued, I guess. So are we actually using iteration enough, and when is it appropriate to iterate? And that's one of the things I'll talk about a bit more later. But where this led to in our thinking is we often see fixation in design. We often focus on one possible solution when there are alternatives to be considered. And so we wondered, in this next experiment, we looked at how the change in a process. So what if we have people, instead of just iterate on a solution, what if they try out different solutions in parallel? And instead of having the egg drop problem as our experiment, we picked another design domain. It's similar in the sense that it has an objective outcome. There's a measurable way to look at the solutions. And it's also very diverse. There's not one possible answer, but many valid solutions. And so what we did is we had people design web advertisements. And they were going to design ads for the same client, this student-run magazine called Ambidextrous. And the nice insight here is that we could take the ads that people create and launch them onto the web and gather analytics about how well they performed. How many people clicked on the ads based on how many times they were shown. And how much time did people spend on the website once they clicked on the ad. So we had people create ads using the same graphic design editor. And in the study, each participant created 5 preliminary designs, 5 prototypes, and then a final design. And that final design was going to get launched onto the web. So in the serial condition, it was an iterative process. They would create a design, and they would get some feedback on their design. They would create another design and get feedback on that design, and so on. In the parallel condition, first they would create 3 designs, and then they would get feedback in parallel on all 3 of those designs, followed by the creation of 2 more prototypes, and parallel feedback on those 2 prototypes, followed by the final design. So it's a very much a kind of an explore and then narrow in. Everything was held constant in this experiment except for the timing of the feedback. So in the parallel case, the feedback was delayed, essentially. Whereas in the serial case, feedback came after each design. So what kind of feedback did participants receive? Here's an example. What we did for this experiment is we generated a small corpus of critique statements before the experiment started. So we had 50 pre-canned critique statements that you might apply in a graphic design situation. And during the experiment, we had an expert select 3 of those canned critique statements to apply to each ad, to attach to each ad. So they had to make sense for what they had designed. And the important thing is these statements were very technical in nature, not positive or negative in tone, and they were equal across conditions. They were similar across conditions. Any questions at this point? So in the end, we got a bunch of ads. Everyone created a final ad, and we launched a 15-day ad campaign through myspace.com. Anyone still have a MySpace account? Come on, you can admit it. We generated about 1 million ad appearances or impressions. And what we found in the experiment was that web users clicked more parallel ads per appearance than the serial ads. And not only did the parallel ads attract more clicks or more visitors to the website, once they got to the Ambidextrous website, those visitors spent more time navigating around. So not only was it collecting more people in general, it was getting the web users that are actually interested in the content, which is great. And we also saw that independent raters, both the ad professionals and the clients of this magazine, were rating those ads higher than the serial ads. So by all our measures, the parallel process actually produced better end results than the serial process. And then we start to look at why this is happening. Why are we seeing a difference in the results? One reason has to do with our basic ability to draw contrast, to compare. So Deirdre Gettner has done a series of these experiments on our human comparative ability. In one experiment, they had people reading case studies, business case studies, and then applying what they learned to a related business problem. And in one procedure, they would have them read a case study and then describe the solution, then read another case study and describe its solution. And then in another condition, the comparison cases, they would first have them read both cases. And then they would prompt them to say, by saying, describe the parallels of these 2 cases. What's similar and what's different about these 2 case studies? So by explicitly asking people to compare, people were 3 times more likely to understand the underlying principle that was trying to be taught through these cases and to apply that to a related problem. And the theory here is that people do a better job of capturing the underlying structure of examples when they can compare. And so bouncing back to the ad study, perhaps viewing and processing these critique statements in parallel, receiving your feedback on multiple alternatives at the same time allows for a deeper understanding of what those critique statements mean in a larger context. The interviews were also revealing. We heard a lot of the same things we saw in the egg drop study. So I tried to find a good idea and keep improving it. I pretty much stuck with the same idea throughout the process. This is a serial participant talking. And we printed out this giant poster of all the ad designs, all the intermediate designs and the final designs across both of our conditions. It's a big poster still hanging up on the wall at Stanford. And we could see more patterns of similarity in the serial designs. And we wanted to quantify that. So we created this measure of similarity where within a participant set of 6 designs, we would look at how diverse or how similar are their set of designs. And so we would ask people on a crowdsourcing platform on Mechanical Turk to look at a pair of designs created by the same participant and say, how similar are these two on a scale from 1 to 7? And so we have many people judging pairwise similarity between each of the participants' 6 ad designs, and we found that the serial ads were deemed more similar, the parallel ads more diverse, according to the crowd. And it raises questions about a very serial iterative process where you create one design and you get feedback on it. Does that actually encourage fixation? Does that keep you framed around the current design you have without considering the other possibilities? Because feedback has the ability to give you very concrete next steps. It's informative about what you should do next, but it doesn't necessarily tell you to look sideways, look at other alternatives in a broad sense. So finally, most surprisingly, we saw several of the serial participants reacting negatively to the critique. Here's an example.
These guys, are telling me that I am completely, doing something wrong here. So it took me a while to get past the I'm a failure at this and to, how can I go about fixing it in the ways they suggested? So there was this short period where there was the emotional response overwhelmed any positive, logical impact that this ended up having.
So 8 of the 17 serial participants reacted negatively in some way to the critique statements, whereas none of the parallel participants did. The parallel participants were less invested in each particular design, whereas if you have only one design on the table, your ability to kind of soak in critique and listen to what's being sort of advised about your designs is much harder. It's much harder to take critique. It's a double-edged sword. It's a place for learning, but it's also a place where you've invested a lot of your ego and your energy and your thoughts. And to have someone kind of come and knock your designs can be can have sort of a mixed effect. Yeah.
So I'm reading all this stuff about Steve Jobs and being lionized as this visionary designer. I'm wondering, in this study, for example, how did this parallel serial effect, for example, dominate the inherent talent of the designers individually?
Certainly there are individual differences between the participants, and we see that in any experiment. The thought behind using randomized selection and evenly distributing people across conditions is that it balances out across conditions, and we're looking for those effects.
If you took, let's say, the best designer and the worst designer, would we see a larger disparity than between the serial and parallel designs?
Yes, because individual differences are going to, have a big effect. You're going to see a huge range in performance. If you take the highest parallel performer and the lowest serial performer, you're getting individual differences in that comparison. So it's kind of it's a strange question to ask. I think a different question is, of all the other effects that could come into play in a design process, is this the most important effect? Are there sort of other effects that dwarf the manipulations we're doing here? That's the sort of thing that's also really hard to tell until you've done experiments over a wide range of factors to kind of look at what relative merits each of these different factors have. I actually do think that this manipulation, the parallel versus serial, is one that's of pretty significant importance, relatively speaking. Not that iterating is bad. In that first experiment with the egg drop, we were kind of saying, well, iteration's good because it helps you learn. But what the parallel process gives you is better exploration, less investment in one particular idea, the ability to compare and contrast and learn deeply about the design space that way. The question that we'll get into later is how do you actually apply that to different types of problem situations.
We talked about this at dinner, that Apple actually famously uses very parallel design as well. They have this thing that tying three module. They start with tying parallel, and they create new parallel.
So maybe, so many design firms do, and Apple is one as well, that use parallel design in their process. And we're not necessarily asking those design firms to change what they do, but to get sort of a broader, ask people who maybe don't use these processes to consider why they're important and to provide some evidence for why they're important. And we're seeing sort of those benefits in this experiment, both in terms of learning within the particular problem domain as well as motivational. Because if you're not able to receive the feedback because you're so invested in what you've created, it's cutting off that channel of input. So in our next study, I was really intrigued by this negative reaction to the critique. If people are reacting negatively to feedback from like a random expert, from someone they never met, how would this play out in a group setting, a more authentic collaborative scenario? And it turns out there's decades of research on collaborative brainstorming. Most of it focuses on this issue of, should design teams collaborate and to brainstorm individually and then pool their ideas, or should they sit in the same room and brainstorm together? And it turns out that controlled studies show that it's better for teams to brainstorm individually and then pool their ideas, because group members can block each other from sharing ideas, get frustrated with bad apples in the group, and free ride on each other's ideas. So there'll be people that stay silent because other people are coming up with ideas, whereas individually they can come up with a lot of their own. However, as Sutton and Hargadon argue, they've done a bunch of studies at IDEO and design firms. They argue that there's other reasons why you brainstorm as a group. It supports organizational memory of ideas. It allows you to build on the skills of your team members to sort of understand what your team members' skills are and leverage those in your idea generation. It builds shared ownership of ideas, which is crucial for actually moving those ideas forward. To some extent, I believe, though, this debate over whether or not to design individually or collectively is a false debate, because any process involves both. You're going to go home at night and think about the problem individually and brainstorm on a problem by yourself. You're going to come together and work on the problems together. So the question that I was interested in looking at is, what should individuals do in preparation for group meetings? What should you do on your own time that allows you to be more effective when you do get together as a group? And prototypes are part of that conversation. As Fred Brooks famously said, prototypes can be more articulate than people. So it's important to have those objects in front of you as you're discussing a problem to be able to see these details, the intricate details of a design, to be able to talk more concretely around them. But having a single prototype may actually focus the discussion only on that one design rather than considering others. And when bringing one design into a meeting, individuals may actually spend a lot of time refining and perfecting that design, in part to look good in front of their colleagues. So an alternative would be to create multiple prototypes, to bring multiple alternatives in concrete form into a design meeting. And in theory, this will help reduce fixation, allow group members to be more critical of their own and others' ideas. However, it may actually complicate that decision process. It leaves more ideas to consider, more implications of all those decisions to kind of play out. So the question that we looked at is, does creating and sharing multiple designs improve the outcome over just bringing one design? And we hypothesize here that sharing multiple designs does lead to better results because it will help people explore more concepts and leave them open to adopting and merging ideas. So again, we had people design web advertisements, this time for faceaids.org, a nonprofit dedicated to fighting AIDS in Africa. And again, we launched the ads, this time through Google's ad network. To introduce the design task for the participants, the director of the Face AIDS program, we play this video describing what they're looking for in an ad campaign. So here's a taste of that.
Who should be the target of your ad? We hope that you'll focus on attracting students, high schoolers or college students, who already have an interest in community service and social justice. And we want your ad to spark them to start or join a FaceAid's chapter on their campus. We hope that your ad will be professional and tasteful, visually appealing, but also creative and inspiring. We'd like you to use imagery that is positive and uplifting rather than negative. So we want people to feel empowered by the opportunity to make a difference, not depressed by the scale of the tragedy of HIV/AIDS.
So the video clearly communicated the goal. It also added legitimacy. It was for a good cause. They're designing ads that will help this organization help many people. So for this experiment, we recruited 84 participants and put them into two-person teams. So the experiment started with an icebreaker activity. They were building Lego towers, and then we would break the towers down. That was pretty fun. And then to start out, we had them go to individual workstations in different rooms. So they were given the same problem, shown that video, and asked to create their initial designs independently. Then we had them come together for a group meeting where they would discuss each other's designs, and we would prompt them to provide feedback or critique to their partner. What would you do to help, what would you suggest to help your partner improve their design? And then they spent a little time talking about what would be sort of the ideal design for this problem. And then after that, they went back and individually created their final design. In part because we didn't want to say who would control the mouse if it was like a group design activity. But more importantly, we wanted to see how people adopted their partner's ideas and sort of combine their partner's ideas with their own. Would they share some of these design elements and incorporate them, or would they stick to what they had done earlier? So our study occurred over this part of the process. There were 3 conditions. In the share multiple condition, participants created 3 preliminary designs and then brought those 3 into the group meeting. In the share 1 condition, participants spent the entire design time on one ad and then brought that ad into the group meeting. So there are 2 designs in that group meeting. And then finally, in the share best condition, participants initially created 3 preliminary designs, but we asked them to select the best or their favorite to bring into that group meeting. So again, there were only 2 designs in that group meeting. And we did this to separate the effects of creating and producing multiple designs from that of sharing multiple designs. All 84 participants created a final ad, which produced a wide variety of results. Some of them are good, some are pretty cliche. We got a mixed bag of ad designs. And we again launched a 12-day ad campaign on Google AdWords and generated about 500,000 ad impressions, and also had experts rate the ads, including the FaceAid's clients. And what we found in the experiment was that web users clicked more of the share multiple ads than the other 2 conditions. The share best and share 1 were not significantly different. They're about the same in terms of their overall performance. And moreover, the ad clients and the experts that we asked to rate the ads all rated the share multiple ads higher than the other conditions. And again, we can start to think about, why does creating and sharing multiple designs lead to better results? For one, it helps to have more ideas on the table. An experiment done a few years ago by Brian Lee and his colleagues found that when web designers have a corpus of websites to look at and peruse while they're designing, they're going to produce better websites, more highly rated web designs. So it helps to have more options on the table, to be able to see alternatives and diverse perspectives. So were there differences in how each condition explored different concepts? How much did that group meeting affect what designs people came up with in the end? To measure this, we used the same similarity technique that we did in the first study, so the pairwise similarity within each participant's set of designs. And the data showed that the ads in the share multiple condition were the most diverse compared to the other 2 conditions. And that diversity, or that transformation, came to a large extent after the group meeting. So something that happened in that group meeting allowed those share multiple participants to more diversely transform or diverge from what they had done earlier. They're more open to kind of moving away from what they had done, whereas the share best participants tended to stick to a final design that looked a lot more like their initial designs. So the fun part about this is looking at what we saw in the interviews. And what we saw is, again, some of the things that we saw earlier in terms of sticking with earlier designs. So here are share best and share one participants talking about what they did.
How did your peers critique affect the design?
Not that much. I think they look pretty much like what we started with.
Well, neither of us really said that there was anything wrong with the ad, so we didn't really say anything that we didn't like.
Well, you can see like they're not, completely transformed out. They're fairly similar to what we came to the table with.
I don't think the discussion had any effect on how I went about doing it.
I mean, you didn't give me that much critique, so yeah, you're pretty nice about that. So I don't know, it didn't help me that much.
Now contrast that with the share multiple participants.
I think it's good to see. Yeah, just see
Two different takes on it.
Yeah, because when I saw yours, it was like completely different.
Yeah,
So
we both come to it from each other.
I think we changed the way we approached it.
Mm-hmm.
Sort of to I don't know, the best of both worlds.
Yeah.
Pretty much have the same elements, just in different places. About the logo, a picture of a child, click here to reach out, and then we have a little slogan that's a little bit different.
So we wanted to quantify this notion of how much borrowing happened between designs. So we counted the number of features that migrated from one participant's earlier designs to their partner's final designs. So the partner didn't have certain graphical elements in their earlier designs, but suddenly they appeared in the final design after being exposed to their partner's designs. We would count that. So for example, in these two ads created by different people, there's a similar reddish background. There's the same catchphrase being used, and there's also sort of this college-age demographic being represented in the images used in the ads. And so we would count up these features like this, and it turns out that the participants in the share multiple group did far more borrowing of concepts than the other two conditions. Much like a design studio, people learn by being exposed to other people's work and being able to see the space of possibilities. And not only does it expose specific features, it starts to communicate the underlying thought process of your partner by being able to see multiple designs. So notice this in the share multiple group.
I really like just what you say on each of that. But my impression is this might be a little bit too plain. If you could just add some color, just the background color, it'll be more powerful. I really like this theme.
So she is able to see a theme emerging out of multiple designs and be a little more critical about specific things than what we'll see in the share one condition. So what you see in the groups that were only critiquing one design, what do you guys think will happen in the groups that are only critiquing one design? What do you think is going to happen in this next video I show?
I'm not going to critique it much.
Not much. What's that?
More timid.
More timid. Yeah.
Pull their punches.
Pull punches.
If you have multiple designs, someone tends to walk away with one that is relatively landscape, maybe since they're complete strangers that might be preserved about.
So I was kind of expecting to see a little more fighting for their own idea or defensiveness, similar to what we saw in that second study with the effect of the critique. But what we saw was this.
It's missing a lot. As the first one I did, so And I didn't know what I was doing, so I had some problems.
Yeah, no, I like it. I'm wondering if this might look cooler with this picture over here or something like that.
So lots of silence and hesitation, and when they did make comments, they tended to be somewhat superficial, like maybe just move that over to the other side is kind of an easy, shallow kind of comment to make. And as some of the prior research that we've seen in the HCI community, Tauhidi and her colleagues examine whether users are affected by being shown multiple UI prototypes versus individual UI prototypes. And it turns out that users are better at providing feedback when shown alternatives. And part of that has to do with their ability to pick and choose the features they like from each design and do that compare and contrast stuff that we were talking about earlier. But also, they noticed that one of the reasons why, when shown just one design, participants were not able to, or users were not able to provide good feedback, is they were worried about offending the designer. There's a concern with how you affect the person that you're interacting with. And we saw this dynamic occur in our study with participants that shared only one idea.
And she didn't make me feel terrible about what I produced. So even though she didn't make me feel like a total failure.
And clearly she was affected by this interaction. Share multiple participants were more open to the critique they were receiving because they hadn't made any definitive choices at that point. So our studies have revealed a number of quantitative differences and benefits of sharing multiple designs. A simple change in the process not only produced better overall designs, it led to more idea sharing, better blending of concepts, better overall collaboration, I would argue. Many of us have had the experience of brainstorming very early in a design and engineering process. You imagine the whiteboard full of Post-it notes, scribbles all over a large wall. But how does a strategy play out throughout a design process? Many organizations, in fact, create multiple formative prototypes to inform their design thinking. You may recall this shopping cart video from about 10 years ago. It was a Nightline show that was giving insights into IDEO, the design firm's thinking process. And in that video, they go out and create 4 very different physical prototypes and take those out in front of users to get feedback from different perspectives. Multiple alternatives can help refine a design, even very late in the process. So during the Obama campaign, the website, they would have very different versions. They would explore different versions of the website by partitioning off some of the web visitors into the different variations. And then they can measure how many people signed up with their email addresses, how many people donated money. And by having, of course, millions of people arriving each day, they could do something like this. But it was the fact that they have alternatives in mind and they can explore them and get real quantitative measures of which designs are more successful than others. Educators may look for ways to improve project-based learning. Stanford, for example, largely revamped their curriculum in these design-based courses around creating alternatives throughout the process. In terms of our methodology, the idea of using the web to study creative designs was novel and allows us to look at questions about teamwork and creativity and motivation. And moving forward, I want to explore sort of the things I want to do on here. I'm looking at how can we explore prototyping in more complex situations, such as robotics or such as services, where there's heavy sort of engineering on the back end of things, and where parallelism may still be important, but has to be considered maybe in sub-problems or decisions that have to come up along the way rather than the overall design. And how can we better support iteration and exploration in tools? One question I'm also interested in looking at is the economics of prototyping. How do we think and plan out our iterations and our different alternatives when we're thinking about a process? What's the cost justification of another iteration? for example. And also keeping going on these other factors that influence the design process, such as different forms of feedback, different configurations of a team, and how do those affect the outcomes of a process. And that's my talk. Thank you. Yes, Adrian.
Okay, dude, this is so cool. The one thing, have you thought about how, I mean, so all of these experiments were so, they seemed very time consuming, and they took a lot of effort and stuff. And I was wondering if you considered, like, could we replicate this experiment, let's say on Amazon Mechanical Turk, with like, or just, in a game or something, with like 5,000 people, right? 50,000 people.
I would love to do that. Let's collaborate. We actually did another experiment after these studies where we used Mechanical Turk as our participant. So the whole study was run in an online environment. And really it's a convenience to be able to recruit people quickly and not have to like sit in the lab with them for 2 hours. I think that one of the studies was nearly 3 hours long per participant. And there's a trade-off with doing that. You're going to get a lot of people like not really doing the task that we laid out for them. So there's a lot more noise. So you do need higher numbers of people. We can't collect videos, like the beautiful insights that we gained from people talking about their process. We don't get that from online. In that experiment that we ran, it was interesting though. We had kind of a design problem set up where we're looking at does feedback from an external person lead to better results than no feedback? It did. But that we had a third condition where instead of having the feedback come from an external person, we had the person reflect on their own design, and they had the same feedback form that the external person would have used, but it was more of a self-feedback or a self-assessment of their own work. And it turns out that self-assessing can be as effective, at least in that experiment, as the external person providing the feedback. So by having a really nicely designed rubric for self-assessment, it allows you to glean many of the insights that external feedback can provide. But I stress the trade-offs that come from doing an online experiment, and also the necessary time it takes to think about the right experiment to run. Like, yeah, we can like boom, 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 run a bunch of experiments, but unless they're kind of zoomed in on the right thing, it's going to be really hard to kind of sort through the results. Other questions? Yeah.
You touched on a lot of aspects of this problem, parallel versus serial iteration, and some of them like emotions are involved and things like that. But sort of the first order effect, you're kind of doing an optimization, right? And you're trying to iterate and get closer to a global or a good local optimum. And so if you start near the local optimum, it seems like the serial approach might be better, right? Whereas if you start and you're kind of in some space and you have no idea where the local optimum is, you want to search the space, so parallel would be better.
Yep.
So this kind of raises questions that it depends on the experience of the designer and maybe the complexity of the task. So if you have a designer who's super experienced, he can start really close to that local optima.
In theory,
maybe you'd be better off just iterating his one design.
Those are very great points. So one thing that I didn't mention in the talk, so a little bit of data that speaks to your point. We looked at how much experience people had before they started the ad design task. And those who had done ad design or graphic design or visual design prior to the experiment, they performed better than people who had sort of less experience or no experience. So that's one thing you would expect. We looked at the data from those two groups in terms of how much diversity they explored in their designs. Remember that similarity measure? Those who had prior experience, actually, their set of designs were less diverse, were more similar to each other. So arguably what's happening there is they are going to a better starting point, a higher local maxima, and iterating with small variations within that smaller portion of the design space, so they can kind of see past some of the bad designs or less promising areas of the design space and jump to that. And I also agree that there's a difference in terms of the kinds of design spaces that are out there, the breadth of possibilities within a particular problem space. And sometimes you know that. Sometimes you know that it's going to be a fairly narrow set of alternatives as you move through the process, or a very broad set of alternatives that may imply a particular strategy. But in some cases, you don't know that. You don't know how broad necessarily your space of possibilities are until you start entering in and suggesting solutions and seeing what kind of other dimensions emerge. I need to get a slide that has Donald Rumsfeld's quote about the unknown unknowns, because there are things that you know, there's things that you know you don't know, and there's also things that you don't know you don't know. So there's, this is what he said like on the spot in a press conference. There's dimensions of the design space that you perhaps sitting at one point in time can't even conceive. But they come to you as you start working through it, as you start trying things out. And that's where I think prototyping really becomes powerful, because all the optimization you can do at any moment in time can't get those things that are not in your equation. I used to do this as an undergrad, optimization functions. You know, it all came out of OR, operations research, and the stuff that Herb Simon used to talk about. You know, if you know all the factors, you can optimize for an optimal solution. But the problem is we're fallible. We don't know all those factors. And only by entering in and trying solutions can we best sort of over time optimize on a solution. Yeah?
I'd be kind of interested in an experiment where you had participants build maybe like 5 different egg drops. You know, and then they choose the best one. And then you also randomly choose one and see which ones do better. Something like if people actually know that they're optimizing correctly, or whether it's better to kind of keep them spread the whole time. Because we talked about like the 9-3-1, going down to a single one. I don't know if you have any experience with it.
I think it might get into the issue of feedback is not an unlimited resource, both in terms of testing physical designs. You know, we can't test a car. Egg drops is not kind of a toy example, but you know, if you have some physical design, you don't have unlimited resources for testing that car. Materials cost money. Prototyping materials cost money. Feedback from people actually is not an unlimited resource. You only have so much time to talk to your advisor. And so getting people to think about the limitations of that resource of feedback and how they might, you know, carefully choose which alternatives to test, I think is an interesting point. Yeah?
A relevant problem here could be to see how seed ideas created by someone else could impact a creator. And I would be interested in seeing in your ad design campaign if some participants were presented with a number of 8 or 4 different ideas, would that limit their creativity or open up new spaces?
That's a great question. There's actually been a bunch of research on examples and how they influence creativity. And there's a big debate on this, because what these studies have shown is that people do, when they look at examples, and it came out of the research, remember earlier in the talk, the sketching of aliens. So they had people sketching aliens or creatures from another planet, and they would show them examples in some cases no examples. And the people that were shown examples would tend to borrow and steal the little features, or they would tend to resemble the creatures that were shown. And so people borrow ideas, fine. Does that necessarily make them bad? Does that necessarily limit their creative thoughts? Another researcher came along named Marsh, who showed that not only, yes, they do borrow features, but they also come up with a lot of their own ideas on top of those features that are being borrowed. In fact, no fewer creative ideas came out of the group that were exposed to examples than those that were not exposed to examples. And I think the idea of looking at how examples influence people is a really interesting topic. It says something about how we might structure like an example gallery of designs when it's appropriate to look at examples. So I'm getting ready to run an experiment that looks at if we expose people to examples at the very beginning of a process or perhaps somewhere in the middle, does that change how people think about the design space and how they fixate on one solution or another? So I think it's a really interesting thread. Kayvon, do you have a question?
Oh, do you have any, does this tell us anything about how to optimize the creative process of like computer science research?
Of computer science research?
Yeah. So for example, I'm thinking about this, right? And let's say I have n resources. I have 5 students. And there's 3 projects. So this could argue that maybe the best thing is for everybody in the group to work on project 1 for a while, do a bunch of parallel thinking, and then come up with some good ideas and then set one student off on that. And then have everybody in the group work on project 2 for a while, instead of our traditional way of saying, here, why don't you go work on this, versus you go work on that.
I think that's reasonable. That's
Curious.
one way you could play on it.
About
I think another interesting question I get is how does this work in a software engineering process? Which I think is a very interesting question because software is somehow fundamentally different than making egg designs or making ads. There's a process in creating there's a length of time that it takes to actually produce the vision of what you're trying to create. But what I think it may imply is that when you sit down to create, or if you have a design in mind for a piece of software, think about what alternatives you might want to create for that software. Don't necessarily create all 3 as independent sets of code, but one might think about the way that you can build the software in a way that allows sort of later backtracking and going down another path. So what are the core modules that you can build that will work for all 3 alternatives, for example, of the end result of a software process that would allow you to maximally shift directions as you start to get that informed feedback. A lot of times, though, software processes begin with a plan, and halfway through the process they realize they're building the wrong software. And so what I'm trying to advocate here is for a lot of flexibility in terms of how much you put into the final plan. I think it's okay to have a vague idea of the final end result because you're going to learn as you're moving through the process. Yeah.
So it's kind of similar to Kayvon's question, but applied to robotics. So 2 of the classes here, one is how we show sits general robotics undergrad class, and the other one is John Bowman's mechatronics class. They have basically both these classes, they're hands-on designing robots, and so they have groups of 3 work together, one computer scientist, one mechanical engineer, and one electrical engineer, and they iterate through different design, different building different things, and at the end of the semester they build a bunch of different robots. And so I was just curious if you had any thoughts on that process. In some ways that's different, qualitatively different, because you have people from 3 different disciplines coming together. So, it's not necessarily like they're all bringing some, things, parallel things to the table that they would be competing or being defensive about, but they have to kind of really all bring their own thing to the table and put those together. I've seen certain bad trends. I've taken both those classes. I've seen certain bad trends happen. For instance, it's much harder to iterate. It's much harder for a mechanical engineer to iterate because it takes hardware. So the software engineer ends up kind of having to be very flexible around the mechanical engineering, and so things like that can happen. I was just curious if you had any thoughts on that.
I think that sounds great. I'd want to study that a bit more because I think about the dynamic we set up in that study, as powerful those videos are at showing how the process can affect dynamics among people. There are many other real-world team configurations that we're not getting at. We're kind of setting these people up as strangers, for example. What if you know each other? Are you more comfortable being critical? Or what if you each have a piece of the puzzle, like it sounds like this situation is? Or what if there's a power relationship? One person's a boss, the other one's a worker. And I think it does say something about the configuration of the process. But yeah, it sounds like an interesting one to come and observe and see what kind of things matter in that situation. Yeah?
I just wanted to add that when the students have a pseudo sense of being in competition, or maybe a very real sense of being in competition with each other, the critiquing can vary so greatly too. That's part of the talk is trying to get good critique, thoughtful critique.
That's right. Yep. And in robotics, it's interesting because there are different kinds of feedback that you're going to get. Some of it is critique that exists over an idea or a rough mechanic that you're trying to figure out. Some of it is real-world physical testing. Does it? No, we'll get to that too. Then there's user testing where you actually have some goal in mind or some use case where people are going to users are going to provide feedback on, yeah, I would like to have that robot hanging around or no. And so there's sort of a wealth of different types of input that come in that inform the final design. And I guess that's sort of an obvious statement, but to think about, what are all the different ways that your end result can be affected, and how do you optimize sort of the feedback? How do you think about where you're going to spend those moments of getting feedback? I think is an interesting way to sort of come back to the optimization question that someone asked earlier.
Can I just ask another one too? The first idea rut. What was the way that you seemed to find that people could get out of that? They got hung up and stuck on their first idea. I just keep reiterating. Polishing a turd is the term that I've heard.
Yeah, we're looking a lot at reflection, different reflection activities. So I started going down this route of people fixating on a particular egg design. What kind of things would help them break out of that, right? So it gets into what kind of questions people ask of themselves, or trying on different perspectives. We had people think, okay, now what if you have to drop that egg vessel off the balcony, off the 4th floor balcony? And that got them thinking, oh, okay, we're not talking about distances of 10 feet, but of whatever, 50 feet. That may change. Okay, now I'm thinking about it a different way. Or what if instead of an egg drop vessel, it was an astronaut coming into the atmosphere and they're going to land in the ocean, and you want to protect the man from a fall? What sort of things does that provoke? And so get those sort of thinking processes that get people thinking outside the box, reconfiguring the space, like the candle problem. The fact that dumping the tacks out had such a significant effect on how quickly people could solve that problem. So I think there's sort of a series of things, and I'm not the first person to say this. I mean, there's been techniques and method cards that have been invented that help people sort of reframe and rethink the problems that they're stuck on. But I think it's ultimately recognizing when you're stuck on a problem and taking action to try to get out of that rut. Yeah. Oh, you had your hand raised before.
So
okay.
Back when we were explaining the experiments, the single versus parallel creation, I was wondering if you had any thoughts or intuition about what might happen if you used that same set of participants, but each cycle where they got feedback, you had a different person from that experiment sit in that and then take over that aggregation project. So, going off of the thing where the series users become emotionally invested or sort of sidetracked by that.
Right. So there's actually there's a researcher at Stevens Institute of Technology named Jeffrey Nickerson who's working on doing some of these experiments, these sketching experiments in crowdsourcing platforms where the initial sort of round of the crowd designs, for example, some chairs, and then they give those designs to a second round of crowd members who build off of the designs. And so each generation is sort of building on the earlier generation of designs. And they had some interesting results. I think that that needs some more exploration to understand sort of what are the main points or strategies in terms of structuring that task. But I think that's something that's, we're going to try to work on that here as well. So if you guys are interested in talking to me more about ideas, I'm happy to meet with you, and thanks for your time.